நார்மல் பேசிட்டு இருக்கும்போதே you give me an example for approximation. Approximately. Yes, please. Price, right. Approximately it will be. I ask you to go and search for or ask for the price of 2 kilograms sugar. I don't know, actually no. I don't know. The shopkeeper says any amount, I will only give it and get it back. But you go, you will ask for that, right? No, last week it was this much and this week it's this much, right? Petrol price, anything, prices of, please, commodities, things, right? Then experiments, results of experiments. You have to get a result, but you may not get the same result. You may get a result approximately close to that result. Okay, good. Then you understand what I am asking at least? Then I am happy. Balance approximately. And you can say that measurement of a desk, length of your desk is also an experiment. Simple experiment. You have to have a scale, but for this you can say almost accurate answer. See, you have a scale, measure it. But there are, now I go back to say, these are classical examples of measurements, applications, prices of commodities, all are classical examples. Almost for all classical examples, I hope you understand. Almost for all classical. How many students are here? 2, 4, 6, 8, 10, 11. Classical examples. Classical example. You can count. I give you, yesterday I said one example. Today, these examples, yesterday we were not having. Shall I say the yesterday's example? It will be interesting because 1 to 2 minutes only to take. I give you 500 rupees, right, with the denominations of 10 rupees each. 500 rupees, denominations of 10 rupees. How many 10 rupees would be there? 50. I give you 500 10 rupees note. The amount will be 5,000. Now I ask you to count the 500 notes. You have started. I give it as, it's not an assignment. I treat it as the play. You start to count. I give it to her first. She counts and says that, sir, 497 papers are there. She may say like that. I give it to Muthulashmi. She says, sir, 502 notes are there. She may say like that. You had your own experiences for this. So you understand this now. So each and everyone is expected to say 500. But you may say that, sir, 496 only, sir, 4 notes are missing. You may say, no. There comes approximation. You have to say accurately. Right? Is it a classical example or quantum mechanical system example? It's a classical example, no doubt in that. So no error has to be there for this. If you do mistakes in this classically, then you cannot go for quantum mechanical. So, say classical, small example to count the notes, right? So, now system, you mean system, you mean what? Again I go and say the classroom is a system. You accepting? This is a classical system. What do you mean by quantum mechanical system? Give me one example for that. Number of students is classical system. Just now I said, you know, classical system. A quantum mechanical system. So these are all things which you have to be very strong. Then only we can go into it. Go to that approximation. Classical system. Number of students inside the classroom is a classical example for a system. The system is classical. Quantum mechanical. Very simple. I want you to give one example, that's all. Hydrogen atom, atom in general, hydrogen atom, helium atom. Because when you do study to the scale of atomic size, then you get into quantum mechanics. So to go back, where we started quantum mechanics. If you do go like that, you will get things. Now, is it to count 2, 4, 6, 8, 10, 11 classically is very simple. Mistake or error is less, very less. You need not go for approximations. Now, quantum mechanically saying, need not go to that atoms. I have some handful of lead shots. Then again I ask you to go and count it. You cannot be as sure, as accurate as of distance. I accept it. You cannot be as sure as the case of counting the number of students. You may be missing, and the elements, the balls are not conducive enough to handle. You have to take utmost care, right? So this is quantum mechanical system. Now, problem is approximation. Where approximation comes, we have to give one example. Hamiltonian, you know well, right? Now, I write the Hamiltonian of Hamiltonian in general is equal to, yes please? B plus C. What? And this is equal to T plus V classically saying, right? Quantum mechanically saying also T plus V, but T and V you have to write in terms of quantum mechanical operators and the coordinates for that. I hope you don't understand that. H is equal to T plus V. Accept it. T is equal to again you put one straight line. We are still down. Yesterday also I said, right? You are right but still down. You are right here. I want you to get right here. You understand? You are right here, my dear. I want you to get right here. Right? Please go back to again the same thing. Omni is right? Good, right? And this is B. Now I want you to write it here. You understand the straight line? Hamiltonian H is equal to, if you do answer speedily, also I can go speedily, I can go fast. Right? Anybody else? Right? We have to write for V as well. We have to write for V as well. I have given you the example as hydrogen atom. As you know well, for hydrogen atom there is only one electron. So you do write the V for that. V for that electron in the, or that atom, hydrogen atom is, how to write V? V is equal to, general, if you do say that, yesterday the girls said the general formula for V. You again start to say general formula for V, classical formula. V is equal to, G is equal to, I am writing here this side. I am writing here this side. V is equal to MgH. Okay. See, my dear, I am very happy to get some answers. No wrong answer, but the answer is not applicable to our place here. Half? Okay. Anything else? I asked you to think about the electron and the atom. MgH is right. So let all them can enjoy this video clipping by saying this, by explaining why it cannot be the answer. V is equal to MgH is there. I am ready to put as many videos as like this possibly, because even this half an hour about this, many students may not aware as you, right? So V is equal to MgH. You are right but not here. You are right but not right for this place. Half kx square. Again you are right but not right for this place. We can write V as many ways. Yes, please, my dear poor boys. Long back, I think when I was doing my BSc, I saw one movie by that movie, Four Brothers. The movie title is like that. Beautiful movie, fast movie. Four brothers are there. They do act unitedly for a cause. Beautiful, fast movie. Starts and ends immediately. So the four brothers can say one answer now fastly. Is it not that? V is equal to K, Q1, Q2. K is equal to 1 by 4 pi epsilon 0. If you want, you can write it in that way. V is equal to 1 by 4 pi epsilon 0, Q1, Q2 by. Is it R square? Potential. Yesterday there also problem. Fight was there. Somebody says R square, somebody says R. Force. So you go back and if you do right R square, you will become force. Force is directly proportional to the charges and inversely proportional to the square of the distance between them. Potential is directly proportional to the charges and inversely proportional to the distance between them. So V is equal to K by R. Now V is equal equal to, I will say minus z e square by r. Is that? You would have seen this. Z e into e. The charge and charge. And r is there. Now we have to make use of this d here in this place. Z e square by r. Then you have to start to apply coordinates equations. You know well that equation, right? Coordinates time independent equation is there and time independent equation. These two are this. H size equal to yes. D size and another one. I is equal to dou psi by dou t is equal to these. Last semester we studied these things, right? You must remember. Yes, please. Exercise. Now, I don't want this. I want this one. Exercise is equal to this side. This exercise is your exercise. Right? Suppose I do have helium atom as an example. Then, how do you write H? See, if I give a problem to you, you must be ready in a position to write the Hamiltonian for the same. I treat my students strong enough in that strain. How do you write, sir? How can we write, sir? How do we know, sir? We don't know, sir. Don't say like that. Think it over. See, you understand this now? That's all. See the problem. See the problem. What's the problem? Who are the people in the problem? Who are the people in the problem? Here in hydrogen atom, people are one electron and that nucleus, right? So take these two and try to write potential energies for the same. Now I am giving you two atoms, helium atom, two electron atom, helium atom. How to write H for this? H is equal to, how to write H for this? The same thing, minus h square by 2m. In that case, minus h square by 2m, 1, then 1 square, plus d1 plus d2, minus h square by 2m2, that is 2 square. See, because we are having 2 electrons. This. In addition to these 2, in addition to these 4, we are having some other people play a role for Hamiltonian. These are all not our problem here, but after having good understanding about approximations, you have to apply all these approximations to these types of problems only. These are all the problems. Now the problem is hydrogen atom, helium atom, harmonic oscillator. You can have it as a problem.